Today in this video I'll teach you how to draw the circuit diagram for Ohm's law, and also we will see the experimental verification of Ohm's law. So before going to that, let me tell you we are doing videos related to current electricity chapter. We already did these portions, that is electric current, potential difference, resistance and resistivity, and we are on Ohm's law. We did the statement of Ohm's law in the previous video, so those who are watching for the first time, please go through the previous videos, at least the Ohm's law video, so that you'll understand this video easily. So the links of those previous videos are given in the description box, so please refer those videos before watching this video. And those who have not subscribed the channel, please subscribe the channel so that you will get the continuous video lessons that are being taken. So let's start. Last class we stated Ohm's law. We understood that Ohm's law is a law which is relating current, potential difference and resistance. So I'll just state the law once more. Ohm's law states that the current flowing through the conductor is directly proportional to the potential difference across its ends, provided physical conditions and temperature remains constant. And we also did the equation for Ohm's law as current is directly proportional to the voltage which is being given, and we did the equation as V is equal to I multiplied with R, or IR, where R is the resistance. Now today we are going to learn the circuit diagram, how to draw the circuit diagram. Now before going to draw the circuit diagram for the Ohm's law, I think you need to understand the components which are being used for the experiment. So I'll just make you familiar the components which are being used for the experiment. So this is the voltmeter, and voltmeter is used for measuring the potential difference of the cell. So this is the voltmeter. It will you can see a letter V there which represents voltage or volt, and the numbers are there 0, 1, 2, 3, etc. and one needle is there which shows the reading. A needle will be showing the reading. Then there is a positive terminal which is red in color, negative which is black in color, and I have shown you the symbolic representation of voltmeter. One circle within it we'll write V, then positive sign for positive terminal and negative sign for negative terminal. Now the next component that we need is an eliminator or battery. So here I have shown the battery. This is the eliminator. This is actually a variable eliminator. We can adjust the voltage, but eliminator with only one voltage is also there. Then here this is the positive terminal, this is the negative terminal. Positive will be red and negative will be black. Now this is the symbolic representation of battery. So the long line is the positive terminal and the short line is the negative. So if you are drawing only one long line and one short line, this is a cell. If more than one cell is combined, like I have shown here, we call it as a battery. So I have shown here a battery because we have two cells combined. Then long line should be written as positive and short line as negative of the battery. Now the third component is the rheostat. Rheostat means it is a variable resistance that can be varied. So that is known as rheostat. Now rheostat is actually used for varying the voltage. That is, if you vary the resistance, you can vary the voltage. So this rheostat is used for varying the voltage by varying the resistance. You can see certain wires which are wound over the tube. So that is actually resistance wire itself. And you have a sliding slider here. When you slide it on towards left or right, you will be adjusting the length of the wire of contact, and thereby adjusting the resistance, thereby adjusting the voltage also. Then you can see terminals here, top here, then here and here. Okay, so not here, it's not here. So here bottom two screws are there, and here there is another screw where we can give the connection wires. Now that is about the rheostat. The symbolic representation of rheostat is curved like a crocodile like wire, symbol. Then this one, that is see, actually these two portions are the bottom connections or bottom screws, and this one is the top screw. Okay, so that is about rheostat. Now moving to the resistance, that is we are finding the value of resistance in the experiment. That is, we need a wire or a conductor. So we usually use a nichrome wire for doing the experiment. So this is the nichrome wire, and the representation of resistance is like this. That is simply like crocodile or that wavy symbol without any arrows. If you are putting an arrow, it will become a variable resistance. This is a constant resistance. So that is about the resistance. So this wire may be of 25 centimeter or 50 centimeter, can be used for doing the experiment, for using it as a resistor or a conductor. Now the next component is a key or a switch. So here I have shown a plug key. In this case you can see a black colored thing, so you can pull it out and keep it back. When you are pulling it out, current won't pass through it. There will be a gap in between and current won't pass through it. When you are keeping it closed, the current will pass through it. So it will act as a key or a switch. So the symbol for a closed switch or a key is shown here. This is plugged in. This dot shows that the switch is in on position. Now the next component is the ammeter. So ammeter, there you will see A written on that. So that is how you can identify ammeter easily. Then readings are here 2, 4, 6, 8 like that. Then one needle is there which shows the reading. So the needle will go right when the current increases. So if current is 4 ampere, it will show like this. If current is 8, it will show like this. So the needle can move when the current flows. Here also there is a positive terminal and a negative terminal. The symbolic representation of ammeter is a circle. Inside it the letter A is shown, and negative should be shown and positive should be shown. So these are the components that we are going to use for doing the experiment or for drawing the circuits. Now let us see how we are going to draw the circuit. So for drawing the circuit, it is better to start from the cell. So first you draw a cell. So here I am using a battery, so I am doing 2 cells, and you need the connection wire. So this is the connection wire. So you can show connection wire using straight lines. Then after that we are going to connect the cell. So here you can write positive of the cell, here negative of the cell. Then from the cell, in order to control the voltage, we have the rheostat. So draw the rheostat. So I hope you remember the symbol of rheostat. One arrow is there. Then this is the symbol of rheostat. Then from the top of the rheostat, that is from the arrow of the rheostat, you keep or you give the connection to the key. So you draw the key and let it be closed. From the key we can give the connection to ammeter. So A, ammeter. Getting? Then from the ammeter, it is better to connect it to our resistor. that is the nichrome wire which we are going to use, that is the resistor. So you can name it as R, and from the positive you just connect it to the resistor. Now one more component is there, that is our voltmeter. So voltmeter should always be connected across the resistor. Across means you have to connect the voltmeter here like this, V. Okay, that is across the resistor, potential difference. So this point and this point should be connected across the resistance. And the ammeter always should be connected in line with the resistance, straight line with the resistance. Okay, so the ammeter should be connected series and voltmeter should be connected in parallel. Now I have told you about a positive and negative of the ammeter and voltmeter. So always the cells positive should be facing the voltmeter and ammeters positive. So if cells positive is here, then voltmeters positive should be here, negative should be here. Okay, see, cells negative is here, so the ammeters negative should be here, positive should be here. So that is how we have to connect the ammeter and voltmeter. Cells positive and negative should be considered while connecting the ammeter and voltmeters positive and negative. So this is the connection diagram for doing the experiment Ohm's law. I hope you understood how to draw the circuit. Now we have to draw the direction of current. You know that current flows from positive to negative. So the cell is having positive here. So the current will be flowing from positive, means it will be flowing from positive. So arrow should be shown like this. So this is the current which is flowing from positive. It will flow through the resistor, it will flow through the ammeter, it will flow through the switch rheostat and will come back to the negative. So this should be the direction of current in the external circuit from positive to negative. So that is how we do the circuit diagram for doing Ohm's law. Now let us see how the components are connected. Let us find out how to do the connection. So for that I have drawn here the picture again. So all the pictures, all the diagrams are actually same only. See the cell is there. Now we will see the actual connection of the components. The circuit diagram is given on the right side. The current direction is shown using red arrows. Positives and negatives of ammeter, voltmeter and cell is also shown using red pen. Now we will see the actual connection. We will start the connection from the eliminator or the battery. So battery is positive is there, negative is there. You take a connection wire, copper wire, and connect the positive of the battery to the resistor. So using a connection wire you do that connection. After that you take another connection wire and from the negative of the battery you wind the wire and connect it to the rheostat bottom screw. Then take another connection wire and from the top screw of the rheostat you connect the wire to the screw of the key. Then using another connection wire, the other end of the screw of the key is connected to the ammeter. Then after that you have to give the connection from the positive of the ammeter, red color of the ammeter, to the resistance. Now almost the connection is done. Now we have to give the connection of voltmeter finally. For that we need to take two wires and connect it to the positive and negative of the voltmeter. Then connect the positive of the voltmeter to one end of the resistor and negative of the voltmeter to the other end of the resistor, so that the voltmeter is now connected parallel to the resistance. So that is the complete connection. And when you look at the direction of current, the current will flow from the positive terminal of the battery, will move towards the resistor, through the ammeter, through the rheostat, and will come back to the negative. So it will start from positive and will move towards the negative. So that is the connection which we give for verifying Ohm's law. Now let us see how the Ohm's law experiment is done. For that you have to first switch on the battery so that the current will flow through the battery. Make sure that the switch or the plug key which we have used is also plugged in. Now after that I have told you about a slider here for the rheostat. You can slide it towards left and right. So you slide the rheostat and you just check the ammeter reading and voltmeter reading. So when you are sliding the rheostat, you could see that the ammeter reading and the voltmeter reading is changing. So you slide or keep the position of the slider of the rheostat in such a way that the voltmeter, let it give a reading of let it be 1 volt. That is, you slide the slider so that the voltmeter shows 1 volt reading. At the same time you note down the ammeter reading. So when you note down the ammeter reading, you get it as 0.5 ampere. I am just giving a value. After that, what should you do? You should again slide the rheostat slider. So when you are sliding, you could see that the voltmeter reading is changing, ammeter reading is changing. Now you place the slider in such a way that you get 2 volt in the voltmeter. Then at the same time you note down the reading of the ammeter. So you get that it is 1 ampere. Write down the readings. Likewise, you slide the you slide the rheostat in such a way that you have adjusted the voltage. You have different values of voltage, and you correspondingly you take the reading of the ammeter so that you get the reading of the current also. So that is how we do the experiment. That is, by sliding the rheostat we adjust the voltmeter reading to 1, 2 volt, 3 volt, 4 volt, etc. Then correspondingly we will note down, or we will see the reading of ammeter and we will note down the reading of ammeter in a separate column. So the readings are actually shown here. That is, when we slide the rheostat, when it is 1 volt, you got the reading of ammeter as 0.5 ampere. Then you again slided the rheostat, thereby changing the voltage to 2 volt. Then you got the ammeter reading as 1 volt. Then again you slided the rheostat so that the voltmeter reading shows 3 volt, and then you got the ammeter reading as 1.5 ampere. So this much of current is flowing. So you got a set of reading, 4 sets of readings are there. Now when you analyze the set, you could see that when we are increasing the voltage, the current is also increasing correspondingly. That is Ohm's law. When voltage is increased, current is increasing. So you got you found that Ohm's law is correct here. And also when you calculate the value of resistance using the equation V upon I, you get, for the first case it is 1 upon 0.5, 2 ohm. For all the readings, if you calculate the resistance V upon I, you get that the value of resistance is 2 ohm. That is the value of resistance. Resistance here, I told you earlier that we are going to use a nichrome wire. Okay, so the resistance is actually the wire, 25 centimeter or 50 centimeter of wire which we have used, that is having a resistance of 2 ohm. When we are doing the actual experiment, may not be due to some errors and all, may not be we don't get the perfect value. It may be 2.1 or to 1.8 like that, but anyway it will be somewhat approximately equal to the value, or you could see that the range of reading that we get or values that we get for resistance is almost constant. So from the tabular column we can verify that Ohm's law is correct. Now let us draw the graph of this tabulation or this experiment. So when you are plotting a graph, you can plot the graph in such a way that voltage is taken along y-axis and current is taken along x-axis. Now I have given the voltage as 1 volt, 2 volt, 3 volt along y-axis. Then I took the scale along the x-axis as 0.5, 1, 1.5, 2, 2.5, etc. Now when you plot the graph, you know that for 1 volt it is 0.5. So here I have 1 point. Then for 2 volt it is 1 ampere, so I have second point. Likewise for 3 volt it is 1.5 ampere, third point, and fourth reading is here. Now from the graph and when we are not applying any voltage, current will be 0. So if you draw a straight line, or if you complete the graph, you will get a straight line. That is, if those which are obeying Ohm's law, the VI graph will be a straight line. So if it is a straight line, that straight line will be having only one slope, and the slope of VI graph will give the value of resistance. You know, slope is actually ratio of, or dividing y difference to x difference, that they will give the slope. Now let us find out the slope in this case. So here, for finding the slope, you select any 2 points. So I have selected these 2 points which are circled in red color, and there I need to find the y coordinate difference and x coordinate difference. So y coordinate difference is actually this much, y difference AB, and x coordinate difference is this much, that is CD. For these 2 points you can select any 2 points. So when you take AB, it is actually a difference between the points 4 and 2, that is AB, 4 minus 2. So that is written here. Then CD means it is the difference between this 2 and 1. So that is 2 minus 1. So when you calculate, you will get it as 2 upon 1, or the final answer, slope is equal to 2. But you know that slope is actually what? The resistance, V by V upon I. So graphically also we got the same value, 2 ohm. From tabulation also we got the same value, 2 ohm. So this is how we verify Ohm's law through experiment, and by drawing graph, and by tabulation. Now instead of drawing VI graph, we can even draw IV graph. That is I along y-axis and x along, V along x-axis. That is just the reverse of the other axis. There also you'll get a straight line. But here actually if you are finding the slope will be giving 1 upon resistance. So if you want to find the resistance of IV graph, okay, you have to find the reciprocal of the slopes. Find the slope and find the reciprocal of the slope, that will give you the resistance. But if you are taking VI graph, that is V along y-axis and I along x-axis, that is the first graph which we have done, then directly the slope will give you the resistance. So keep this in mind. If it is VI graph, slope itself will give the resistance. If it is IV graph, that is changing the axis, then resistance will be given by the reciprocal of the graph. So keep that in mind. So that is all for today. The other portions will be taken in the next video.